Welcome back, I'm Professor Steele, and today we're going to look at exact values created with our angles. In trigonometry, we have certain angles that we can determine the exact value of both the horizontal and the vertical measurement. These exact values, we are going to develop them using basic geometry. So if we have a unit circle, we know that the radius is 1, and if I put a equilateral triangle in it, what can you tell me about an equilateral triangle? Well, we know the sides are all 1, have a length of 1, and we know each angle has a measurement of 60 degrees. So if we focus on just half of that triangle, we know if this is 60 degrees and this is at 90 degrees, then this reference angle created is 30 degrees. So if I took that full equilateral side and cut it in half, then I have a measurement of 1/2 on this particular side. And again, like we said, we're just going to look at the top half. So to determine the value of our point right here, we know horizontally, we've got to determine this value. Vertically, we have a measurement of 1/2. So how do we determine the third leg in a right angle triangle? If you said Pythagoras' theorem, you're correct. We have this side squared, we'll call it our x, is the hypotenuse squared minus the perpendicular side squared, which gives us 3/4. However, that was x squared. So x is equivalent to radical 3 over 2. Yes, we would have two values. However, we only want the positive since we're talking about this measurement. So we just determined that horizontally speaking, the cosine of 30 degrees has a value of radical 3 over 2, and the sine value of 30 degrees, in other words, the vertical distance of an arc created with an angle of 30 degrees, is 1/2. And that is the coordinates of this point, radical 3 over 2, comma 1/2. This is our 30, 60, 90 triangle. We're going to look at the same triangle, but pivoted. Instead of being 30, 60, 90, we'll create our 90 here. We will now have our reference angle of 60 degrees with our 30 degrees being up top. So in this triangle, now our x is this shortest distance. We have our radius still of 1, and we have the vertical measurement. Now in this particular situation, since we pivoted, the shortest side is now known to us as 1/2, and the unknown is the longest side. Well, since we just looked at a 30, 60, 90 triangle, and we know the two values, if our horizontal distance now created by the 60 degree angle is 1/2, then the sine of that 60 degrees is radical 3 over 2. So this point, the angle created of an arc with 60 degrees has a horizontal measurement of 1/2 and a vertical measurement of radical 3 over 2. Now we will look at our 45 degree triangle. In other words, our isosceles triangle. For our 45 degree triangle, we still have a radius of 1. However, we don't know what this horizontal or the vertical measurement is, so we're just going to call them A. We do know that they're equal since this is an isosceles triangle. So we know 1 squared is equal to A squared plus A squared, again using Pythagoras' theorem. So we have 1 is equal to 2A squared, which means A squared is equal to 1/2, and A equals radical 1 over 2, which is equivalent to radical 2 over 2. I'm not a fan of rewriting our radicals, but you're going to see the benefit of this rationalizing the denominator. You'll notice we just determined in a triangle with an angle of 0 degrees, our horizontal measurement, cosine, is the length of that radius, which is 1, and we know our horizontal measurement when the angle is 90. We don't have much of a triangle. Our horizontal measurement is 0. We just determined that at 30 degrees, the horizontal value is radical 3 over 2. At 45 degrees, the horizontal value is radical 2 over 2. And at 60 degrees, we have radical 1 over 2. Do you see a pattern occurring here? In fact, this 1 could be written as radical 4 over 2. So So if you notice, there is a little bit of a pattern going on. Radical 4 over 2, radical 3 over 2, radical 2 over 2, radical 1 over 2, 0. Those were our cosine values because they are decreasing from 1 to 0. Conversely, our sine values, our vertical measurement, starting at 0, our vertical measurement's 0 at 90 degrees, our vertical measurement's 1, and they do exactly the reverse. Radical 1 over 2, radical 2 over 2, radical 3 over 2. And we know we don't need a radical over 1, we can just simplify it to 1/2. This is a simplified form of using our exact values. These values can be applied in any quadrant using our reference angles. We'll look at that at some thinking problems coming up. Thank you for watching. Please make sure to like and subscribe, and I'll see you next time.